In this video, in fluid mechanics, we shall see about the properties of fluid. What are the basic properties of fluid? Density, specific weight, specific volume, specific gravity, compressibility, bulk modulus, viscosity, other properties of fluid. Now we shall see the properties of fluid in detail. First is density. What is density? Density is defined as the ratio of mass by volume. The unit of density is kg per meter cube. It is denoted by the letter rho. Then is specific gravity. What is specific gravity? Specific gravity is the ratio of density of the substance whose specific gravity has to be found divided by the density of standard substance. What is the density of standard substance? The standard substance is water and its density is 1000 kg per meter cube. Then is specific weight. What is specific weight? Specific weight is the weight of the given substance divided by its volume. So the unit of specific weight is Newton per meter cube. Then is specific volume. Specific volume is the reciprocal of density. What is specific volume then? It is the ratio of volume by mass. So the unit of specific volume is meter cube per kg. And some specific gravities of some substances are given in the tabulation. Then is vapor pressure. What is vapor pressure? The pressure created by vapor is called vapor pressure. When a container is filled with some liquid and it is closed with a lid and it is heated at a higher temperature, what happens? The fluid in the container gets vaporized and it is collected between the lid of the container and the surface of the fluid. The vapor accumulated and vapor is accumulated between the lid of the container and the surface of the fluid. And the vapor accumulated between the space creates a pressure over the surface of the liquid and the lid of the container. This pressure is called vapor pressure. The pressure that is trapped, the vapor that is trapped creates a pressure, and this is called vapor pressure. Then is compressibility. What is meant by compressibility? Compressibility has got a very good relationship with the density. When a fluid is compressed, its volume decreases. When its volume decreases, obviously its density increases. So when the liquid or fluid is compressed, its density changes with respect to its pressure. This is called compressibility. What is viscosity? Viscosity is the resistance created by the fluid to its flow is called viscosity. For example, when you pour water and oil simultaneously, water moves faster than oil. Why? Because the viscosity of oil is much higher than the viscosity of water. So the viscosity can be explained as the internal resistance of fluid which could resist the movement of the fluid. Now, kinematic viscosity. What is kinematic viscosity? Kinematic viscosity is the ratio of dynamic viscosity and density. So the unit for kinematic viscosity is meter square per second. It is denoted by the letter nu. It could also be denoted by Stokes. What is Stokes? What is the relation between Stokes and our SI unit? The relation between Stokes and SI unit is 1 Stokes is equal to 1 centimeter square per second. Surface tension. Surface tension is the tension created on the surface by either atmospheric pressure or object over this fluid. on its surface. This is called surface tension. The unit for surface tension is Newton per meter, and it is denoted by the letter sigma. Then is capillary effect. What is a capillary? It is a narrow or confined tube through which water can be filled. What is capillary effect? When this capillary is immersed in a bowl of water, the level of water in the tube gets raised over the level of water in the container. This rise in water level in the narrow tube is called capillary effect, and when there is rise in the liquid, it is called capillarity rise. And when this same narrow tube is immersed in a bowl of mercury, the level of mercury in the narrow tube will be much lower than the level of mercury in the container. This is called capillarity fall. The liquid or the mercury in the container does not rise above the level of mercury in the container. This is called capillarity fall. This rise or fall of a liquid in a small diameter tube immersed in a liquid is called capillarity effect. Thank you.